Go. No, you do not get to talk. Hello, Hybrid Bee. Hope everything is going well. Here we go. So this is example 2, and you'll notice it has an or. The last one, on example 1, you notice that the equation was between the two inequality signs. Notice we have two separate inequality signs with an or. This is going to be our union. It means that everything is, we can have either or. That's what a union is. So to solve this, what we're going to do is we're just basically going to solve the two equations. So I'm going to solve this one, and to solve this one, what would I do? Divide by? And 15 divided by 5 is? Now, what am I going to divide by here? -3. I have J, but I divided by a negative. Which sign flips?
Equal to.
Yep, the inequality sign. So it was greater than, so now we're going to flip it so it is less than or equal to. And what is 21 divided by -3? And this is an or. And then we're going to make that nice number line. I know, so much fun. You guys, I always like to give a little wiggle room when I make a number line. I believe that the number lines will be made for you, which is super nice. I say that, and look, I didn't give myself wiggle room on that one side. Okay. Now, is this going to be an open circle or a closed circle on 3? Oh, sorry, I should give you time. What do you guys think? Closed circle on 3. And is it going to be a closed circle or an open circle on -7? Okay. Okay. So you guys, J is greater than or equal to 3. So we're going to shade this way. And this is why my arrow is so bad. So the only thing is if you do put like the dot above and then the line, make sure you color in that arrow. The reason it's important that you color in that arrow is it means that it goes on forever in that way. That's the symbol. And then J is less than or equal to -7. This means that -7 is part of the solution set. And then I want numbers less than -7, so it's going to go this way. And why this is an or, usually ors go in opposite directions. And the reason they do is because you can make either one of those true at one time. They probably both won't be true at the same time, but one of them will be true. So here you guys, this means that 3 is part of the solution. This means -7 because of the line. So we do need to do set builder notation, and we'll do that tomorrow. But right now, I really just want to get you through this example. Okay. Now, I want to point out a couple things for you. So, right here, this study tip is really important. That these right here, that if you have an absolute value, you guys can't see that, this study tip at the bottom of this page, if the absolute value is less than a -5, then it's the empty set. So if you've isolated the absolute value all the way down, right, and it doesn't matter what's inside the absolute value. If you've isolated the absolute value, you could have 4x plus 7. If it's less than and it's a negative number, your answer set is going to be the empty set automatically. if you've isolated the absolute value, that means the absolute value is by itself, okay? There's nothing in front of it, nothing after it. It's just the absolute value, and it's greater than a negative number. That means the entire line's going to be shaded in, and the entire line is your solution. So that is the difference. So this right here is really important that you keep that in mind, okay? Okay. You ready to do example 3? We're ready to do it. Nothing like having Algebra 2 first thing Monday morning, right? Yeah, you guys. Yeah. I know why you guys don't talk. It's Monday morning. It's at 7:30. But I don't know why my 5th period doesn't talk. Okay. Listen, I'm just talking to this thing like you guys are sitting here, okay? Example 3. Is it example 3? Yeah, it's 3A. So this is example 3A. And we have just a really basic absolute value. So when you have a basic absolute value, you guys, it really doesn't matter if it was basic or if there was stuff in it. You would still do it the same way. And so what we're going to do is we're going to set it up 2 ways. Okay? So we have the first way where we would just write t is less than 6, and then we would write t is greater than or equal to -6. And then we're going to graph them.
So you just do like the opposite?
So you all, just like when we did regular absolute values, you would write t equals 6, or and then you would write t equals -6. Now you're going to do the opposite. You just don't have to solve anything. And now we're going to graph it. I'm going to let us get away with just a simple number line, okay? If you have, it is less than. If you see that it is less than, right? This is what we're going to say is an and. So and goes with less than. Now we could graph it and I could show you what I mean. So you guys, again, is 6 included in this solution set? So I'm going to put an open circle around 6. Is -6 included in the solution set?
No.
So I'm going to put an open circle around 6, -6. And now, what we have to decide is where to shade. So I'm going to show you why this is an and. If I plug in 0, is 0 less than 6? Yes. If I plug in 0 here, is 0 greater than or equal to -6? Is 0 greater than -6? It is, so I'm going to shade in between. Okay. So -6 to 6 we shade in, that's an and. It would have, if I put -7, -7 is less than 6, but 7 is not greater than 6. It needs to make both of them true. Okay? Let's do example 3B. Now, first of all, we know. What do we know about an absolute value? Can it equal a negative number? Can the distance away from 0 be negative? No. So we know that there's something wrong. So that study tip I just gave you, what did it say? That study tip I just gave you, it said, if the absolute value of a variable is less than a negative number, it is the empty set. So this right here is the empty set. Automatically.
And that's all you have to put?
That's all you have to put. I mean, there's some other ways that you could put it. You could put the empty set like this. You could put this. Either one, any of those answers are correct. It's, do you know that there's something wrong with the u is less than -3? And you guys, you could actually do the problem, but what would happen is you're not going to get a correct answer. Okay? Because a less than is a compound inequality with and. So, and then I'll have to go back and show you, probably tomorrow I'll show you how to do the set builder notation. Okay. We're going to do one more example before I shut the timer off. I think I can get one more in. So we have the absolute value of t is greater than 3. Okay, it doesn't equal a negative, so we're good. So what we're going to do is we're going to set it up as t is greater than 3, t is less than -3. And we're just going to do that simple line, that simple number line. You guys, I think you can do a simple number line unless I give you a number line, then use that one. But let's do simple ones because I don't need you to be wasting it's not wasting time, but to make a number line, I think that there's more valuable time for you guys. So does it include 3 in the solution? No, so I put an open circle. Does it include -3 in the solution? Now, I'm going to show you why this is an OR, and we're going to plug in 0. Is 0 greater than 3? Is that a true statement? No. Is 0 less than -3? No. So shading in between gives you a false answer. It's not true. So you wouldn't shade there. So we're going to shade this way. And all I had to do was test one number, you guys. If it's false, then you can't shade that way. So this would be an OR. So either or.